Hi all, welcome to my YouTube channel Know About Embedded System. In this today's video, I'll be explaining two important things. One is a one Neumann and one Neumann architecture, and one more is Harvard architecture. What is this one Neumann and Harvard architecture, and how they are different, and how these things will be used in the embedded system. In the slide, now you can see what do you mean by one Neumann architecture. Just now I have explained. In case of one Neumann architecture, the CPU and memory, there will be a single memory here. From this single memory, we will have only one set of data bus and one set of address bus, and this single memory is divided into two parts, RAM and ROM. RAM also it will have its own address, and ROM also it will have its own address. With the help of address only, data bus and address bus are able to communicate with the memory and then CPU. So this concept is called as a one Neumann architecture. And how it is defined: one Neumann one Neumann architecture uses a single memory space for both instructions and data. Both the instructions we will use single data bus, single address bus, single memory. Single bus is used for transferring both instructions and data. Okay, so there will be no separate set of buses to transmit and to receive any instruction. The instructions are fetched and executed one after the other, and CPU cannot access both instructions and data simultaneously. Since we're using single data bus and single data address bus, we cannot fetch data and instructions both together, but instead of that, data will be fetched in the one cycle and instruction will be fetched in the one more cycle. So like that, so data and instructions will be fetched from the memory one after the other sequentially. Such type of architectures are called as one Neumann architecture. I hope this is clear. Very straightforward definition. So we will have single memory, one set of data bus and address bus. On the other hand, we have our Harvard architecture. So Harvard architecture is already explained in brief. So we will have CPU, we will have a RAM, and we will have a ROM. For RAM and ROM, separate data bus and separate address bus will be there. One set of address bus and one set of data bus will be for RAM, and one set of data bus and one set of address bus for ROM. Two different memory, two different data bus, two different address bus. Such type of architectures are called as Harvard architecture. A separate memories are used for the Harvard architecture. Instructions and data are stored in two different memories. Instructions and data are stored in the memory RAM and ROM. In the ROM, instructions will be stored, and in the RAM, data will be stored. Separate buses. Dedicated two buses are used separately for data, separately for instruction, separately for address, and separately for instruction, separately for address. Okay, simultaneously it is possible. Since we're using two different memories and two different buses, simultaneously we can access data, simultaneously we can access even instructions as well. Instructions are nothing but code. And parallel execution. So Harvard architecture is an example for parallel execution, but one Neumann architecture is example for sequential execution. Okay, so this is a one Neumann and Harvard architecture. So by seeing the diagram, you can differentiate both Harvard and one Neumann concept. I hope this video is informative, and please do subscribe to my channel to get more information on embedded system. So with this, I'm just ending my video here. Thank you for watching, and keep on watching Know Our Embedded System. Thank you. I'll come up with the next video.